two-dimensional material as simply gate, or to use doped two-dimensional material to construct the whole FET structure?
You mean using 2D material as the gate? Like for example, this one.
Yeah, you show something about this.
It depends on what kind of characteristic you require for the gate. For the transistor, the requirement for the gate is very different from that of the channel. For the gate, you typically want this material to have certain work function, so you can have a threshold voltage. Because different work function gate give you different threshold voltage. That means your device will switch at different voltages, which is not good. You want the device to switch only on a certain voltage range. And also you want this gate to be highly conductive, so you have low resistance to the gate. And 2D materials, in principle, any conductor can be used as a gate. So 2D material, yes, they can be used as a gate. But do they fulfill this requirement? That is not necessarily valid in all cases. So I've seen people using graphene as the gate, and that will work. It has certain advantage that it's very thin, but it probably have a disadvantage that is still higher resistance than conventional gate. Higher resistance, not resistivity. Because 2D material is one layer. Unless you stack many layers, you have lower resistance. Yeah. So typically gate, we want it to be thick, big, low resistance. Yeah.
Other questions? For me, your experience in doing this very nice work on graphene, what do you think about the perspective for these 2D materials?
That's a very good question. I think I will still go to this slide. I think from theories and from initial bank structure data, we know that 2D materials, if you look at their bank structures, their electrical property, they are quite promising. So I think the bottleneck will be the material synthesis, and it is important to see that there is a viable way to have a scalable and controllable way to control it, to grow the device, the materials. And so far, I think they're still lagging behind of what has been done for graphene for the set amount of time. I think that's partly because of the diversity of the 2D material that could be worked on right now, so it's defocusing. And also, with so many material to pick from, it's hard to decide what would be the, I mean, even for the semiconductors, what would be the best channel material to pick? That's still a very challenging topic as well. And without deciding what material to work on, it's probably difficult for people to focus their efforts to make a breakthrough. And that worries me.
Okay.
Is that a rumor that graphene is replaced by black phosphor?
It's probably not a rumor. A lot of graphene communities have joined the research of black phosphorus. And actually, it's a blessing for these new materials because all the experience and the techniques that was developed previously for the 2D materials such as graphene and even earlier carbon nanotubes could be applied to any new materials that's emerging. And that will speed up the learning. But I think it's important that people stay focused on one material to have a certain breakthrough. If they just jumping around, it will be difficult to have an important breakthrough. That's my my feeling, impression about what's going on in this field.
Okay.
Here.
So a little bit standing away from the academic point of view. So could you please share a little bit experience on your startup a company and go to R&D in a big company? Okay, that's amazing big. I think from Ivy as compared to IBM. But it's TSMC is already a big company. So could you please share the experience and maybe to the young people here? Yeah. Not everyone go to the academy to become a professor. I think this is also interesting, right? Yeah. For both.
Yes, thank you for this opportunity for me to comment on that. Indeed, the 3 years time I spent in helping this startup was, I think, was the most exciting experience I've ever had for for this career. You look at different. You look at this exciting new technology. You have we had a strong opinion. I mean, we have a strong faith that this could make an impact for future, and that's why we come up and decided to do this startup. But you have, once you begin a startup, you have to change the way you think. You cannot just focusing on solutions. I mean, curiosities-based solutions. You really have to come up with practical needs for people, for what other people needs. And also, one fundamental issue in any startup is the funding. How you can have enough money to sustain the growth without burning out. That was also a lot of things that you have to look outside of your original comfort zone. And if given a chance, I will do it again without doubt. So I think it's always worth it to try different things. And especially, I mean, one of the driving forces because I had a belief that it could make an impact. And make an impact to other people, to the field, is really what drives me to make all these choices.
Okay. Following up this question that I'm asking you, and a tougher question you don't need to answer. What's the difference between IBM and TSMC?
Well, the culture is different.
We can cut the recording.
Yeah, then I can probably speak more for